Hello, I'm your Cypher Psych 12 and today we'll be going over week 8's lecture. This week was all about bivariate associations. Firstly, what is a bivariate association? A bivariate association is an analysis of whether there is a statistically sound relationship amongst two variables. For example, people with higher IQs score higher on standardized exams, or even people who exercise more are less likely to go to the hospital. Bivariate association comes in various forms. There's a two continuous variables which is a visually represented through a scatter plot and measured through correlation. There can be a one continuous and one categorical variable which is visually represented through a scatter plot or bar graph and measured through a t-test and group averages. There's a two categorical variables form which is usually visually represented through a table and measured through a chi-square test. Differing between association versus causal claims. Causal claim. One can assume that a claim is a causal claim when a variable has been manipulated. And one can assume that a claim is an association claim when a variable has not been manipulated. Additionally, it's important to note that quasi experiments are in the middle of association and causal claims. Statistical validity of correlations. This might seem like a bit of review from the previous weeks, but I think it's extremely important to comprehend statistical validity of correlation in this course and to always go over what each denotement actually means. In lecture, Professor went over how the R statistic ranges from -1 to 1 and it goes in either a positive or negative direction. Effect size is the strength of the association and is denoted by the R value. The closer to either -1 or 1, the stronger the correlation. And the closer to 0, then showcases how weak the correlation is, even showcasing that there's no correlation. R is similar to D, but it is used for continuous association instead of group association. If R is 0.1 or -0.1, then it's small or weak, which is similar to D being 0.2. If R is 0.3 or -0.3, then it's medium or moderate, which is similar to D being 0.5. If R is 0.5 or -0.5, then it's large or strong, which is similar to D being 0.8. Larger effects give more accurate predictions and are usually more important. Statistical significance is denoted by the p-value, which is the probability that sample utilized in the research was chosen from a population with zero association. If the p-value is less than 0.05, it is considered significant. If it's greater than 0.05, it is non-significant or not significant. Larger effects have some smaller p-values and it's less likely to find a strong correlation by chance. Also, larger samples have smaller p-values and smaller samples are more easily affected by chance. Statistical validity issues with correlation. In terms of statistical validity issues with correlation, we will be specifically looking at outliers, restriction of range, and curvilinear associations. Outliers are extreme scores that disassociated from the general scores. They are bad because they can greatly affect the correlation in terms of strength and significance. Restriction of range is a term used to describe how the correlation appears smaller when there's no full range of scores for the variables. Curvilinear association speaks on normal correlation only works for internal relations, while variables might be related in nonlinear ways. Temporal precedence and confounds. In order to help establish temporal precedence in a bivariate design, longitudinal study designs are utilized. There's designs that set out to measure the same variable in the same participants at multiple time points. Cross-sectional is a comparison of variables within a single time point, Autocorrelation is a comparison of the same variable at different time points. Cross-lag correlation is the comparison of one variable at an earlier time to a different variable at a later time. If one cross-lag correlation is stronger than the other, then it alludes to one variable happening before the other. And if both cross-lag correlations are strong or weak, then temporal precedence is not established. Researchers always have to rule out confounding variables, even if there's an association with temporal precedence. That is all for this week. Thank you.